Bismillahirrahmanirrahim. Allahumma salli ala sayyidina Muhammad. Okay guys, assalamualaikum warahmatullah. Okay, here are example 9.1. Okay, 9.1 from your textbook. Okay, I shall discuss the solutions herewith. Okay, we have a 120 volt 1/4 horsepower 60 Hz 4 pole split phase induction motor with the following impedance characteristic of R1, R2 and magnetizing impedance. And also it was stated that the slip of this motor is 0.05 or 5%. Rotational loss 51 watt. And it was assumed that the losses constant over normal operating range of the motor. So at this slip, find the following quantities. Okay, this is the general quantities that you should able to find out once you are given this parameter with the slip. Usually for your motor, if you require from the market, and this parameter seldomly being supplied, maybe it will supply inside the datasheet per requested, but if not, you only able to acquire the data from the nameplate. You know, the nameplate is stated how much the horsepower, the voltage range, and also sometimes it's stated the line to line impedance. So line to line impedance is the total impedance between line to line, from line to line. So you can use that one to actually find out what is the P-in, and the P-in, and find out the efficiency of your motor. And okay, assume that this data is given. So what you have to do is that you, my advice, you try to figure out and try to visualize what is where. So you write or you sketch the schematics, equivalent schematics of the AC single phase AC motor, and also preferably you can draw this powerful diagram from P in to P out where the losses emitted at. And we have here from P in P out, we have here the first gap is PA gap, then P converted, and PA gap, P converted, then in between we have losses. And before PA gap we have stator copper loss, and means that P in minus stator copper loss, we have PA gap. P in minus stator copper loss minus rotational rotor copper loss, and we have P converted. And so or P converted is equal to PA gap minus rotor copper loss. And so we can visualize what is where. And P out is the amount of P converted minus all the related rotational loss, P mechanical, P core, and etc. Okay, then once you draw the schematics, you need not, by that you should draw and can be as a reference. And so you write down all the elements that involved. And so we have here the first part is R2 divided by the amount of slip. And the second part, this is forward, this is reverse, R2 divided by 2 minus slip. So the JX2 we put in there. So this is 0, half of it, half of JX1 and half of JX2. So magnetizing impedance, we put in the values there, the forward and the reverse. Okay, the amount, you transfer the details here into the circuit and as your reference. So you draw nicely, not for what I draw here, because the pixel pen is very tedious to write or draw inside the screen here. So by right, if you write by pencils or pen inside your sheet, should be better presented. Okay, you write down and list down by right. If you later you see only the circuit, you are able to visualize, and all the data is already tabulated here. You're able to appreciate over there. So we go to the question P in. First of all, how much is P in? And how much is your input power? How much the P in into the system? So actually P in is equal to V in times I in cos theta. how much V in here across your incoming terminal times your V in, also times the cos theta, the angle of your voltage to current. Okay, so P in equal to V in times I in cos theta. But I in you have to calculate, and or you have to measure. If you know the in between the terminals of the in terms of the impedance, so you can use that. And the total impedance, V in minus by total impedance, you get your I in. But this one, we are given the details in terms of their impedance individually, in terms of their R1, R2, and impedance, magnetizing impedance. So V I in is equal to, so P in equal to V in times I in cos theta. And I in here we have to find, which is V in divided by total impedance. So V in provided 120 volt, but Z impedance we have to calculate. So Z impedance is amount of R1 plus JX1 plus Z here, and half of Z forward and half remain as Z backward. So 0.5 Z forward plus 0.5 Z backward. So that is your impedance and total impedance in between terminals. But we have to calculate again what is the Z forward and Z backward. So Z forward is equal to Z impedance of RF plus JXF. So Z forward here is the amount of, we combine a parallel the R2 over S with JX2 with the 0.5 of JXM, and so we shall have the Z forward. And so Z forward is equal to RF plus JXF. And meanwhile, for this amount values, we have to calculate parallel the elements of R2, JX2, and JXM. We shall have R2 plus over R2 over S plus JX2 times JXM, and the below value we just plus them all together, JXM. So what you have here is that, so what we have here is that 2.8 divided by the slip value divided by S plus JX2, which is 2.56, times JXM, which is 60.5 ohms. So the below value we add all of them together. 2.8 divided by 0.05 plus J 2.56 plus J 60.5. So we solve them part by part, and 2.8 divided by 0.5, you get the answer, and then you plus this one, you get the answer, then you times this one, you get the answer. You write down the value first, then you calculate the below value after that, and so you get the answer of 344.176. Better put in polar form, because sometimes you calculate in complex number, you usually make mistakes, so better put it in the polar form. Calculate the above part, put one side, and then you calculate the below part, which is 2.8 divided by 0.5, you get the answer, plus J 2.56, you get the answer, then plus again 60.5 J, and you get the answer, you put above here, below here. Then you divide the polar value, you should get for this part 25.161 in, and you put it in polar and also in complex number, and 25.161 and also in polar number for 0.838 and at the angle of 51.966 degrees ohm. So this is your value of your Z forward. This is the value of your Z forward, which is in polar form 40.838 and 40.838 here, 51.966 ohm. This one in complex number. Okay, then you calculate the Z backward and the Thevenin equivalent circuit of your Z backward and Thevenin equivalent impedance. Sorry. So Z backward is equal to R backwards plus JXB lah. So same like Z forward, RF plus JXF, so RB plus JXB. But this Z backward is the amount or the value of R2 over divided by 2 minus S. And so you parallel the circuit of R2 over 2 minus S plus JX2 times JXM divided by, you plus all of them, the element together. You paralleling the impedance. So you put in the value, which is 2.8 divided by 2 minus 0.05 of the slip value plus JX2 of 2.56. Then you parallel or you times the 60.5 and minus the same number values of the amount of all the impedance mixed or plus all of them together. So you settle the above parts and you write down the result, preferably in polar forms. So you will do less mistake if you convert the amount into polar and you write down the answer here, and then you divide by the above the below numbers or the below values, which is you solve part by part. 2.8 divided by this one, get the answer, plus this one, get answer, plus this one, get answer, put it here. And so 63.076. So you will get the answer in the complex number and polar form. 1.32 plus J 2.486 ohms, or in polar form 2.815 with the angle of 62.016 ohms. So ZF you got this number. So Z backward you get with this amount and 2.8. So you can see the forward impedance is higher compared to the reverse impedance. And okay, so you go back to your In, which is In is equal to Vin divided by all the total impedance, which is Vin divided by R1 plus JX1 plus 0.5 Z forward and 0.5 Z backward. So you put the values in, which is Vin is equal to 120 volt, R1 is 2.0, JX2 is 2.56, 0.5 of ZF, which is 0.5 times 40.838 with the angle of 51.996 or 97, plus 0.5 of ZB, which is 0.5 times 2.815, 62.016 ohm. Then you divide them by 120 volt. You shall get, you solve this one first, the below value first, 25.056 with the angle of 52.535, and then you get your numbers or the value of 4.789 with the angle of 52.535 ampere. And so don't forget to put the unit and also the symbol. So this is in phasor. So means that you have a 4.789 ampere with the angle of 52 degrees of lagging from the voltage signal. So you can solve for your Pin, which is Vin times In cos theta, 120 times 4.789. So you get the number of